Okay, let's look at another example finding limits based on the graph. So we want to find the limit as x is approaching negative 3 of our function f of x. So again, we're going to take the one-sided limits. So the limit is x. Okay, so let's look at another example of finding limits graphically. So we again want to find the following limits based on the graph below. And so we know that in this case, the first one, the limit is x is approaching negative 3 of f of x. So again, we're going to find the one-sided limits. So limit is x is approaching negative 3 from the left of the function f of x. And so as we do that, coming into negative 3 from the left, it's coming into 5. So limit as x is approaching negative 3 from the left of f of x is 5. Limit is we come in from the right of f of x. So coming in here, we're also approaching 5. And so because both of these values agree, 5 is equal to 5, then we know the limit as x is approaching negative 3 of f of x is 5. Similarly, now let's do the limit as x is approaching 4 of f of x. So same concept, limit x is approaching 4 from the left of f of x. So coming into the left, we're going to positive infinity. Limit as x is approaching 4 from the right of f of x goes to negative infinity. So because positive infinity does not equal negative infinity, this limit does not exist. Alright, limit as x is approaching 2 of f of x. Same concept. Notice when you look at it graphically, you can see as we come into 2, both sides are approaching 1. So even though f of x is defined to be 3, the limit is going to be 1. And again, we verified that because the limit is x is approaching 2 from the left is equal to 1. And the limit as x is approaching 2 from the right, f of x, is equal to 1. And because both of these agree, we know that the limit as x is approaching 2 of f of x is equal to 1. And yes, you're probably thinking, do I have to write out these one-sided limits every time if I can just look at the picture? Yes, you do have to write out the one-sided limits every time, or you will lose points. Alright, so now let's try limit as x is approaching 6 of f of x. So limit as x is approaching 6 from the left of the function. So as we come into 6 from the left, notice we're coming into probably about negative 1/2. And then limit as x is approaching 6 from the right, we're coming into 3. So negative 1/2 does not equal 3. The limit does not exist. Notice, looking at the graphically, we have a jump going on here. The next one, limit as x is approaching negative 2 of f of x. So same concept, limit x is approaching negative 2 from the left of the function. So as we come into negative 2 from the left, we're coming into right around 3. Limit x is approaching negative 2 from the right, f of x, 3. So because 3 equals 3, the left and right hand limits agree, so the limit as x is approaching negative 2 of this function is 3. And now let's look at our last one. So limit as x is approaching negative 5, so as x approaches negative 5 from the left of the function. So we look, what's going on here is we come into the left at negative 5, then we're approaching 4. Limit as x is approaching negative 5 from the right, f of x. So coming in from the right, it's also coming into 4. So because 4 equals 4, the left and right-handed limits agree. And we have that the limit as x is approaching negative 5 of f of x is 4.